Okay, just going to go through some simple probability problems. You've got a worksheet full of these sorts of things. I just want to make sure you're aware of how to calculate and how to write them. So the first question I'm being asked is, what's the probability of scoring a 5 on a standard dice, unbiased? Now, unbiased means it's fair, or die, sorry. So that means fair. It means that there's equal chance of getting everything. Of 1, 2, 3, 4, 5, or 6. Okay, so there are 6 options. And the important things to realise is, first of all, often you'll see a notation saying capital P is equal to, and then inside they put the situation, the event we are looking for. So the probability of a 5 is equal to the number of 5s. How many 5s are there? Well, there's only one 5. It's not the score, it is the number, over the number of outcomes. So how many different things can happen if I throw the dice? So the number of outcomes is 6. So that's the probability of scoring a 5. Take a moment to think, what does this ask for? It's asking me what's the probability of scoring 2 or 3. So the number of 2 or 3s is 2 over the number of outcomes, which is still 6 for a standard dice. You do not have to, unless they are told to. Only if you are told, simplify in a question, or simple as possible, or simplest terms. If the question doesn't mention simple, you are fine to leave your answer like that. If the question says simply, or simplify, some variation, what's the simplest form of 2 over 6? Both of them divide by 2. Divide them by 2 and you get 1/3. Only if you are told to simplify. Last part is, what's the probability of not having a 5? Well, that's everything else. Now, one thing to remember is if the total probability available is 1 or 100%. So not having a 5, there were 6 things could happen. One of them was a 5. So 6 minus 1 is 5 ways of getting a 5, which gives me a probability of 5 out of 6. So 6 things can happen. There is one 5, and that sum gives me this 5. It's not the 5 here, it's the 5 from a subtraction. Okay? So I could easily do the same thing with another number. So if I say the probability of a 3 is 1 out of 6, the probability of not 3, a fancy way of saying not is to put a line over it, is the 6 minus 1 is 5 over 6. Okay. Next question is to do with next section I want to do with is cards. I'm playing with cards. So we've got some cards here, and we want to know what's the probability of a queen. And we look down the set of cards and we know, there's my queens. There's 4 of them. So there are 4 queens in, we're going to ignore the jokers. The number of cards you should now know are 52. So that's 4 queens out of 52 cards. That will simplify, but you don't need to. It will simplify to 1/13. Because each suit is the same, some people look at, there's 1 queen in 13. That doesn't necessarily say the probability of getting a queen from a deck of cards, but what it does say is it shows the probability of a queen from a deck is 13 out of 1 out of 13, simplified form of that fraction. The probability of a queen from a suit, actually I'll write 4 at 52, which is 1/13. The probability of a queen from a suit, take one suit, one queen, 13 cards in the suit. So the probability of a queen from a deck is the same as the probability of the queen being drawn from a whole deck, from a suit. Okay. Similar other problem to what we said before. Probability of a club. Those sort, that's clubs, is how many cards in the suit? 13 out of 52, which is 1, simplifies to 1 out of 4. Yes, we've got 4 suits that are the same size. Again, we've got the same probability. And the probability of not having a club is everything else to add this up to 1. So it's 1 minus 1 over 4, which becomes 4 minus 1 over 4, which is 3/4. Everything else gives me that probability. You get some counter games, things like this one. How many counters are there altogether? So the number of outcomes is 12. That's 6 plus 4 plus 2. So if we're asked what's the probability of a red, there are 6 reds, divided by 12 outcomes, the number of reds. Probability of not red, everything else. Or we've got 12, take away those 6, and we're left with 6 out of 12, which both can simplify to half. The reason we don't often do this is so we can make comparisons. If I say the probability of green, it's easiest if we work with the same denominator to decide which one's bigger. So the probability of green is 4 out of 12. The probability of not getting a green is 12 minus the 4 is 8 out of 12. And the reason we don't always simplify the fractions is if we've got the same denominator, it is easier to see it is more likely to get red than it is green. So if we look at the 6 over 12 is bigger than 4 over 12, that tells me that probability or likelihood is more for red than green. Okay. You get situations where you don't know what's in the pot. So you might get asked, you get told certain things going on, and you might get asked, what's the probability of pulling out a red? What's the probability of not pulling out a red? And these are often given in decimals because they're done by experiment. You don't know what's in the pot apart from 10b, so you keep pulling them out to see what's happening. Okay, so if I told you in this pot, you're told the probability, 10 beads, probability of a blue is 6 out of 10. From before, we can say the probability of not blue, remember remember the line over means not, is, well, there's 10 things can happen, 6 of them blue, that means 4 others are not blue. You could have a different vase which has, so that's 10 beads in and 6 are blue. A different pot might have another situation where we've got, we know there's thousands of beads and we don't know exactly how many. And there's red, yellow and green in there. We get told the probability of red as a decimal number is 0.75. The probability of yellow is 0.10. And to work out what the probability of green is using calculator. So to find out what green is, we know that the total must always be 1 or 100%. You cannot do better than 100%, that is certain, and you can't do worse than 0%, that's impossible. When people talk about evens or 50-50, we've got 50% evens, or some people call it 50-50. Okay, so we've got a total of 1. Well, from these two parts we get 0.85. So the green must be 1 minus 0.85, which is 0.15. That's the basics of nearly all the simple probability questions you will get. Okay, so you might want to split these up into different situations to review.